going to happen when I pour and when I put this metal ball into a tank of cold water. This is the cold. This is the hot. What's going to happen whenever I drop this ball? No, write it down.
Can we ask questions about the ball?
We're gonna ask a question.
It is a metal ball.
Hollow? Hollow?
No, it's got some liquid in it. You can hear liquid.
What kind of liquid?
Is it sealed?
It is sealed, yes.
So this is abstract, this is not concrete.
Yes, because she's demoing
Thank
it.
you. Would you please make a prediction? And write incomplete sentences.
Do we have to? This.
How many words do you have to be?
Enough.
I think blah because blah.
And justify your claims.
It only happens to me usually.
This.
Like a mark will grab a hold of everything.
Okay, guys, are you ready? All right. I'm going to pull a name out of my digital student picker to read your prediction. Elvita, not here. Hi.
Look it out.
Good. Ashley D.
Okay. I think the metal ball will float with the part that is liquid will be underwater because that part that's inside the ball will be the same density as the.
I'm sorry. I can't. I'm sorry. Can y'all?
Yeah.
Y'all want us to talk louder, or do you want the fan off?
Talk louder.
Fan off. Okay. How about we turn it off for now, and I'll turn it back on whenever we start the investigation.
Can we compromise and turn it down and speak up a little bit?
Use our teacher voices.
Okay, teacher voice.
I think the metal ball will float with the part that is liquid. Will float. With the part that is liquid, it will be underwater because that part is the same density. And I can draw a picture.
Okay. Yes, draw pictures if that helps. Okay. One more person.
Great.
Pamela.
I just made something up. I just wrote, I think the metal ball will float in the hot water because the liquid inside could be antifreeze and I don't know. I wasn't sure.
Well, just to clarify, we're doing the cold water.
Oh, cold water
This is
first?
only the cold water.
Hot water.
Yeah.
It says hot water.
I wrote about both.
Then
predict
hot water.
what
Oh, and then the cold
But
water.
the teacher said cold water.
And she was.
I listened to the teacher.
Okay, so let's start with the hot water, this one. What is gonna happen? Ashley, you said, did you predict the cold water?
Yes, because that's what you told us to do.
Okay,
Yes.
so let's do
Yes.
the cold
Yes.
water first. Ashley said this,
We are.
Oh, do we have to predict the hot water also?
Sorry.
yes, we will, let's do the cold water first. Okay, so ready, cold water?
It's a boom.
Yeah.
Flo, what are you bamming over there?
I was trying to upset me because I was right.
What, you
Yeah, it's
started
not
going down to the
down.
hand?
But it's,
No, I didn't say bad.
how would you describe its behavior in the cold water?
It's,
Bobby.
Jen, what is it doing?
it's bouncing, right? Yes.
Is it, now that it's kind of settled into a position, where is it located?
Below the water surface,
But,
not at the bottom of the waters.
okay. So,
Beaker?
we hear that a picture's worth 1,000 words, so why don't you draw a picture in your,
I was
on your paper, or notability? And just, I know y'all can't see it, but the top of this ball is popping out of the water about a millimeter. I'm glad we did the cold water first because I would not dip my hand into that hot water to get the ball.
Now it's cold.
Okay, now let's talk about the hot water. Same ball.
Well, not the same ball because you just put it in ice cold water, so you gotta give it time to come back.
Okay, I'll
I'll check it.
hold it.
Give us a lot.
Have you made your predictions about what the behavior when we put it into the hot water bath? What do you think is going to happen? Why do you think it's going to happen? That word because is a great tool that we have. If a student is talking or if we are speaking and we don't use because, then we're probably not providing reasoning behind what we're saying, not explaining ourselves. Okay, let's see. Kim, what do you think is going to happen when I put this ball into the hot water?
I predict the metal ball will sink
Because.
because that's the opposite of what happened in the cold water.
So why do you think it will be opposite, the behavior would be opposite of what it did in the cold water? So the
It didn't do what I
metal
thought it
ball-
was gonna do, so
Okay, so the metal ball in the cold water rested at the top end of the water bucket, but you say it's going to go to the bottom of the hot water? Just because it's opposite? Okay, Toby, did you have something to say?
Well, I think she's right in the fact that it's going to sink because the container contains a liquid. And when you start talking about density equals mass over volume, the volume of whatever is inside the container is going to spread out. Now, I realize that it can only have it.
Why is it going to spread out?
Because the molecules are going to be bumping against each other
Why?
more, because the heat of the water is going to heat up the sphere, which is
Okay.
in turn is going to warm up the liquid that's on the inside, and that will increase that volume within that closed system, the steel sphere.
Okay,
Whereas in the cold water, it was condensed or brought to a smaller volume within that contained sphere. So
so
that's
you're
my,
saying that this behavior will change because the water's gonna heat it up?
the liquid that's on the inside.
But this is a fixed volume,
But the volume of that liquid is increasing on
but it's
the
in a
inside.
fixed, there's no escaping. This is
No, I
a fixed
understand
volume.
that's a closed sphere.
Did you want to say something?
Yes.
What do you think?
The hot water is less dense than the cold water, so it's gonna sink faster. It's gonna sink further because that's
What is it?
the ball.
Okay. so
Because the ball is sealed, so the air, when the water heats up, inside, it can compress the air because it has, it has greater mass, but so even if the liquid inside expands, it's just going to compress the air because the air does not have a fixed volume. So that is not going to change. What's actually going to change is the density of the water because, like he said, when things heat up, they spread out because they're bouncing all over each other. So
you're saying it's the difference in density of the two
The
temperatures
the
of water,
liquids.
not necessarily
right,
the
no,
temperature.
that's going to stay the same.
Okay, all right, well, let's see.
Okay.
Yeah.
For the water comes down.
Okay.
I'm not opposed to being quiet.
Regarding what Toby said and then what you, about a closed system, what about a thermometer? Is that not a change in volume of a liquid? Because he was, I wrote what she said, but
Right.
I'm saying that, is that not what Toby said essentially is the change in volume of a liquid?
Well, the whole, as a whole, I think it's, the volume is staying the same, so it's, like, the liquid is expanding inside the ball, but the ball, like, as a whole, the liquid and the ball, the density of that ball is not going to change.
No, I wrote what she said, but because what Laura was saying was the volume of the liquid would not change. And I was asking about within a thermometer, is that not what happens though?
I don't think
It's kind of like when the lake turns over.
Okay, are you ready to watch? Let's see if you're right. Like a metal ball.
It just went to the bottom.
Okay, so it's resting on the bottom. The little spiky end is resting on the bottom.
Can you duck down for just a second?
Or can you lift it up? Well, maybe.
Yes, we'll do the Simba up in the air.
I thought it would be more than one.
Just all of a sudden.
Like I didn't know it was.
No, because.
Okay, and I'm not gonna fish that out.
Depending on the density of the ball.
So you can draw that, put that in your notes.
Spread out the Play-Doh, it's not the same amount of Play-Doh. It's just spread out. Does that make all of a sudden more Play-Doh? You know what I mean? Does that make it more Play-Doh just because I spread it out?
Okay, so you've drawn your observations. Now I want you to write your observations. And when you're writing observations, it's like making a T-chart, but in words. You observed this with the cold water bath, whereas, which is a word that we use for comparisons, you observe this other for the hot water bath.
You still have that info chart from last summer? The data
The
analysis?
one you have is a down now.
I do have it, but I didn't bring it, but I
So
will.
it's the same.
I'll make another one.
That was,
Do you have a picture of it?
I do. Wait, yeah.
Can you text it to me and I'll make another one?
If not, I have. Okay, yeah, I'm not sure if I saw that.
Okay, got mine. Can I give you one more minute?
Yes.
Finish your writing?
There's air in there.
Quick question, is this something that, is it water inside the ball? Did you say it was water?
She did
tell us?
not.
She said
No.
It's a liquid.
Okay.
Said some liquid.
Look at the thermometer.
What?
It is.
That's why
It just stops.
Okay, it sounds like we're done. So my volunteer is Tanya.
Yay, Tanya.
Would you please share with us what you wrote for your observations?
What's your writing?
Looking at it, I know. I observed the metal ball floating directly under the surface of the cold water, whereas the ball sunk to the bottom of the beaker in the hot water. Hold on,
Good call.
hot water.
Good, that's good, short and sweet, to the point. Anybody else want to share your amazing observations for me? Okay, all right. And just whenever you're making your word walls, you can take that opportunity to write those words out on sentence strips, and you can add the English word as well as the Spanish word, or whatever words, whatever language you need in your classroom. I don't have a lot of kids in my classroom. I live in a different area, and I don't have the language that is most often spoken in my classroom is not Spanish, and I don't know how to write Korean, so I just give the kids little Korean dictionaries, so they have access, little digital things that they can look up the English words with the translations. So keep that in mind. Okay, now predict what will happen. So draw a little line. We're starting our next thing. Predict what will happen when a watermelon, such as this one, and a grape, such as this little grape, both of them are room temperature, the water is room temperature. What will happen to each of these when they are placed into this tank of water? And provide reasoning for your prediction. All right, let's hear what you think, Tim.
I predict that the watermelon will float in the water and the grape will sink to the bottom because the grape is more dense.
Does the density of each of those matter? I mean,
I'm
what
actually as a student, so I'm still a student.
is, are you, okay. Is
Wait,
somebody
what is
else
that?
want to add to that? Tim said that the watermelon will float and the grape will sink.
But then when you ask that
because the
question,
watermelon is,
No, the
because
grape
the
is
grape
more
is
dense
more
than
dense than the watermelon.
but then you asked the question, then you said something else. So what was the last one you
I
said?
said I'm going with student stuff because I'm acting like a
Oh,
student.
okay.
And that's what a student answers.
Okay,
Since I obviously do not know the answer
obviously, come on.
at all, and I really don't. Basically, well, I said the grape will sink because the molecules are closer together, which would make it more dense.
More dense. Okay,
And then the watermelon is, molecules are more spread out, but it's also water.
okay.
When you're displacing the watermelon's water with the grapes, it's just,
Okay.
there's not really much to go.
That's a good one.
So
I mean, I
guess-
wrote it different.
I was thinking that you're relative to the water.
Would you read your prediction?
Oh, well, after you asked your question, I thought what you were going for. But I put the watermelon will float and the grape will sink because the grape has more mass per volume. But I needed to add relative to the water.
Okay, so you said the same thing that Tim said, but you added one piece, right? So, Tim, if I put the watermelon in that tank without the grape, what is it gonna do?
Float?
So does the watermelon's floating or sinking depend on the grape?
No.
Okay, so you wanna rephrase your prediction?
Sure. I predict that the watermelon will float in the water and the grape will sink to the bottom because the grape is more dense than the water.
Okay.
The watermelon is less dense than the water.
Okay, do y'all hear the difference?
Yes.
Okay, so if he said that the watermelon would float and the grape would sink because the watermelon was
Less
less
dense
dense
than
than the water,
the water in the tank
and the grape
is
is.
more dense than the water.
Okay, so let's see if you were right on that.
You also have the bananas.
Okay, ready? Watermelon, be prepared to record your observations.
Weird shaped watermelon, no.
You wanna toss
Don't
it in there
break
like a
it.
basketball?
I gotta eat that later. I'm just kidding.
I'm not, I apologize.
Put those in coolers all the time.
Oh, yeah, the bananas.
Put them in cooler.
All right, record your observations for the watermelon.
I gave you a banana. I didn't realize you were.
Now the grape. Teeny tiny little grape. Whoop.
I got some stuff to write.
So you could say, man, you sink like a grape.
Float like a water.
Instead of sink like a lead weight, somebody who can't swim.
Now, is there a certain percentage, let's see, here's the math connection, of how much the melon, let's say you got another melon, a little bit bigger, or maybe a little smaller, that is above the surface compared to the other melon of a different size that is above the
I think that
surface.
sounds like an excellent investigation for you to do tonight when you go home. You can go to the grocery store on the way and buy a whole bunch of melons, and then go to the pool or the river.
The river.
Yes.
Oh,
Okay.
they escaped me.
Now, Toby asked about a banana. So, what do you think? What?
Use that. Good stuff.
Top will help us.
There you
There you
go.
go.
Okay, here's a banana. What do you think it's gonna do?
Sink.
You think it'll sink? Okay.
The top's gonna float.
Seems pretty thick inside of the
Now peel it.
Any other fruits or vegetables?
Oh, I'm not peeling it because I'm gonna eat that.
Yeah, one thing though, it's
Okay.
not juicy, it's mostly
Yeah.
plant
Now,
fiber.
your observations. We're gonna write your observations. Same thing, I observed blah, blah, blah. Whereas,
I do not say.
And we're not doing conclusions because of this,
no,
that.
you're just writing your
Just
observations. Okay, let's see. Well, heads up, Melissa. I chose your stick. So when you're ready, you can share.
I observed the watermelon floating right above the water's surface, whereas the grape sunk to the bottom of the tank.
Okay,
Of water.
yes.
room temperature water.
See, I have room.
Toby, would you share with us your observations? What did you write?
Well, I observed the watermelon floated in the water with some extending above the top, whereas the grape sank to the bottom of the water of the tank.
Okay,
And I also observed the banana float.
good. You added that banana. You ready? Draw a line. You can illustrate it if you like. Okay, now, yes,
Question.
yes.
So
Yes.
if you heat up the water, is that gonna?
That is a good question.
Because hot water is,
Go home and get
Well, that's what it is, right? Okay, in my hands, I have two sodas. One of them is regular high fructose corn syrup soda.
wonderful.
The other one
Cancer causing.
is diet soda. So, observe the behaviors of the can of regular soda and the can of diet soda when they are placed in the tank. And I didn't write it down, but I would like you to predict what is going to happen to each of these cans when I put them in the tank of water.
And you said that they're room temperature?
Yes, yeah, they've been sitting here all night, as has the water. Rochelle, would you read what you've written?
Sure. I said the Coke will sink because the mass is greater with all the sugar.
The mass of what?
The mass of the soda or the can.
Okay, the mass is greater than the mass of the water?
No, the mass is greater than the Diet Coke.
So what if I didn't put the Diet Coke in the water? Will it still sink because its mass is greater than the mass of the?
Yes. So
So what if Diet Coke didn't exist? Would the Coke still sink to the bottom of the tank? So does the mass of the Diet Coke matter in the behavior of the Coke?
does the mass of the Coke matter to the behavior of the Coke?
So if there was no such thing as Diet Coke in the whole world, would the Coke sink?
Yes.
Why?
Because the density is greater than water.
Okay, so it's, the Coke is going to sink because its density is greater than the density of water. Okay, what about the Diet Coke?
So it would, I think it will float because the density is less. Or as dense as water.
So it will float in the water because the density of the Diet Coke is the same as the water?
It's similar.
Yes. It's closer to the density of water.
Okay, so what, I mean, if it's the same as water, why would it reside up here?
Why?
Why wouldn't it just be in the middle?
Oh, okay, so I guess it has to be less then.
I'm just, so what, you want to rephrase or
Yes.
revise?
Diet Coke will float because the density is less than water.
Okay, okay. Somebody else want to share what you wrote?
I put that, I predict that both cans will float because they have carbonation in the can.
Okay. What does the carbonation do?
Creates bubbles. I don't know.
Okay. Which causes it?
To float.
Because,
There's bubbles always go to the top, always float.
why do the
air.
bubbles go to the top and always float?
Air is less dense than the water.
You got it. Okay, let's test this out. You ready? Okay, Coke, who thinks it's gonna sink? Who thinks it's gonna float? Okay, this is the regular all Coke. And I'm gonna place it in there kind of tilted so I'm not trapping air in the bottom of the can. Let's see, get that in. Okay,
What'd you just pick, Miss Laura?
I turned it upside down. Yeah, it's going back down. Okay,
She was making sure there was no bubble under.
yeah. Okay,
But it's still kind
record your observations. Okay, now we have Diet Coke. You ready? No? Okay, here I go. Okay, now I want you to explain why they behave this way. Write this down. Why did they behave this way?
Laura,
Yes, sir.
are you speaking about these two specifically or in
Yes.
general at this point?
The Coke and the Diet Coke.
So in comparison to one another,
like she's, I think she had a good point
Water,
about
water.
carbonation. When you shake it up,
Or if it makes me.
Dense, heavier than the water, dense than the water. It seems like they get soften it, have a drink that are cool, like the honey or whatever.
the cleanser, whatever.
All the good drinks will be at the bottom, that is doing how to get it, but all the drinks I don't want.
That's gonna shake it. I'll ask her.
Always take it to the bottom. I would get to the bottom, because the dense drink at the bottom.
That's so good.
That's how they do.
But I experiment it.
I know the science behind it, but
Maybe I don't know. Or it's a cylinder and something
bad drinks, so.
Huh? Would you pour it into a cylinder? Will they do it when they're cocaine or whatever? Oh, like if it would keep that whole thing period castle where it adds. We'll wait till she answers first.
That's not a
Shake the can, see if it's changes.
It is, but that doesn't make it.
Two cents. But it's not that much. I am probably with you knowing the answer and still wanting her.
Okay, one more minute.
You know what I mean? Cindy, don't
Well,
do
not
so.
even a minute. Let's do 30 seconds.
No, I don't know, let's find out.
Jen, your name is the one.
I bet it says hot sink.
She's gonna go check it.
Said Jen, mark her out.
Okay.
Okay, I put the Coke sink to the bottom of the room temperature water, and the Diet float at the top towards the surface of the room temperature water.
Because, big word, because.
Because I forgot that part of my sentence. Because the Diet Coke has more sugar and it's not healthy for you.
Why would?
It has less sugar.
So why would that make it?
It's less dense than the water, the room temperature water, than the Coke that is more dense than the room temperature water
Okay,
in the tank.
okay,
I forgot the because part,
okay.
but I did it the other times.
Well, you got there. So write because now. Yeah.
I had an aha moment. 'Cause
What is your aha moment?
yesterday when we were doing putting the liquids in it didn't dawn on me that the corn syrup would act like the honey which went to the bottom of the cylinder. So the syrup in the Coke will cause it to sink to the bottom, just like the,
Good point.
and the Diet Coke does not have the syrup, the corn syrup.
Good.
So that's where I was getting the syrup, the
Your
sugar.
dent, yeah.
Oh, okay.
Yes, ma'am.
So before, whenever you had the metal cylinder, sphere,
Uh-huh.
and you were seeing the volume within it with the volume within it and nothing changed. But with the soda, the volume within it, we're seeing the one that's not diet. The soda within it, the volume within it's the volume within it, nothing's changed. But whenever you kind of shook it, it's floated up a little to the top. Could you not still have the same effect with the metal? With,
But I really didn't shake it. She
but
just
if there's
turned
still
it.
air in it, and if it warms up, we know that warmer air moves more, so could that not have the same effect as the carbonation within the not diet soda?
Well, so, I don't know, you'll have to test that, but I'm thinking that the law of conservation of mass tells me that whatever's in that can is going to remain in that can, whether it's separated out or not.
So could you shake the soda?
So will you
real quick
just shake
and
the
put it in?
soda and then put it in so you can?
I would like to observe that.
Yeah, well, let's try that in just a second.
Okay.
We'll see how
I'm
that
just
works.
curious.
Okay, Brandon, would you share with us your epiphany and your, whenever you start where your students are and working with their past experiences, and Brandon was sharing his past experience with us, and now he understands why this happens.
Well, in my initial prediction, I said the Coke is going to do, sink, and the Diet Coke is going to float. I used the word less this and more this, but that because it seemed to be a thing. But it's actually based on just my being in the pool, like the picnics or going different things. All the good drinks are always at the bottom of the cooler. All the drinks that I don't want, the bad drinks, always at the top. So I remember as a kid, and even as an adult, I'm gonna go get me a drink, a soda, whatever. It's at the bottom of the cooler that I want. But the top of the cooler is always
Water bottle.
the stuff that I don't want to drink at the top.
Okay,
Yeah, that's how
so you're
I
not a
actually
diet
work.
soda man?
That's a real, that's a
But that's how I
Okay,
use it. I
That's
use the word
really good.
less this and more this, but I didn't really know what it meant. I just knew what was at the top of the cooler and what was at the bottom.
Yeah, and that's like Pam talking about, that bubbles rise up, right? So that's why you made your prediction that way. So that's,
I don't think the carbonation, does the carbonation not occur until there's air introduced? I don't know.
the carbon dioxide is in the soda. It's
But-
just
Until you pop it
released
open.
whenever it's in the liquid. So whenever you release it, whenever you open it up, some of that carbon dioxide escapes.
That you hear.
Okay, we're gonna shake for a second. We're not gonna spend any time doing this, but we're gonna see if shaking it makes a difference. Okay, Brenda, tell me when.
Everybody don't listen.
Okay, you ready?
Now open it.
I don't know if you can hear it, but it is, there's no shaking sound, okay? Okay, do you wanna open that?
We should roll it down.
Let's see how far it
Roll
will
it
shake.
downstairs.
Let me get all the gas off of it.
It's okay, you can't shake anymore, really.
Oh, floated for a minute. Oh.
It went to.
It's slightly
still
floating.
saying.
Not for long, yes.
Slightly.
It's because everything's set.
Okay.
Put it in the hot water.
Thank you.
It's inside.
Put it in
Okay, now we're gonna move on. I'm gonna give you a student guide. Take one around. Yeah, how about you hand me that?
Doesn't quite stand straight up.
Gave them all away, thanks. Okay, y'all each take one and pass them down. If there's extras at the end of the table, send them to the other table because I didn't count. So when you get your student guide, I want you to start by defining in your own words. I don't want you to think, oh, I know that this is what it is. Just define in your own words, not numbers, symbols, or formulas, in words, volume, mass, and density. Explain what those are. Just words.
Just words.
Use your words, Jen.
Use your words.
I use my eyes.
Stay here when I'm mad.
That's the real weapon.
Can I stand here when I'm mad?
This is not as much power as that.
You start